Hi, I'm Natalie Meyers, and I'd like to talk to you about text mining for distant reading in order to gain insights into COVID-19. It's a pleasure to be here today at the Extraction Tracing the Veins conference, and I'm pleased to be part of the CODATA Center for Excellence Data in Society mini forum on data extraction. My name's Natalie Meyers. I'm an e-research librarian at the Navari Family Center for Digital Scholarship at the University of Notre Dame. I'm here today to talk to you about distant reading for quick insights using the Distant Reader COVID-19 project. Here you'll learn about reuse opportunities and challenges of text mining COVID-19 papers. The Distant Reader Cord is a high-performance computing system which takes an almost arbitrary amount of unstructured data or text as input and outputs a set of structured data for analysis. It does this work against a specific data set called Cord19 in this case. Reader Cord's code base relies on a prior software suite called Distant Reader Classic, which you can visit at distantreader.org. That project is designed for more generic sets of input and text mining against a variety of sources. In response to the COVID-19 pandemic, the Allen Institute for Artificial Intelligence has partnered with leading research groups to prepare and distribute the COVID-19 Open Research Dataset, known as Cord19. It's a resource of over 130,000 scholarly articles, including a majority with full text about COVID-19, SARS-CoV-2, and related coronaviruses. This freely available dataset is provided to the global research community to apply recent advances in natural language processing and other AI techniques to generate new insights in support of the ongoing fight against this infectious disease. There's a growing urgency for these approaches because of the rapid acceleration in new coronavirus literature, which makes it difficult for the medical research community to keep up. Ours is not the only text mining project against the Cord19 dataset. The approaches and insights are quite numerous because of the COVID-19 Open Research Dataset Challenge. You can find out more about that at kaggle.com. Text mining can be computationally intensive, and the Cord19 dataset grows daily. So for our project, we lean on the COVID-19 High Performance Computing Consortium. It's a unique public-private effort spearheaded by the United States White House Office of Science Technology Policy, or OSTP, the U.S. Department of Energy, and IBM, which brings together federal government, industry, and academic leaders. All the members volunteer and donate free compute time and resources. Other technology industry members include Amazon Web Services, AMD, BP, Dell Technologies, Google Cloud, Hewlett-Packard, Enterprise, Microsoft, NVIDIA, and Intel. The COVID-19 HPC Consortium has expanded in late May to include supercomputing centers and programs in Europe and the UK, and it's quickly grown to include hundreds of petaflops of compute power, major cloud providers, and more than 59 research teams. Members of the Partnership for Advanced Computing in Europe, PRACE, have added their supercomputing platforms to the effort, including the Swiss National Computing Center's 21 petaflops, and the UK Research and Innovation, UKRI, is adding 3 supercomputers, including Archer, a 2.55 petaflops machine. The UK Science Minister, Amanda Soloway, has confirmed that the UK will commit to working with the G7 nations to tackle COVID-19, including sharing research and identifying novel solutions to this novel virus. Tackling COVID-19 coronavirus requires a joint and strong international effort, and the very best minds in science and technology sharing their research and knowledge. By joining this consortium, Soloway said, our leading researchers will be able to access some of the most advanced computers in the world to speed up their research, gain access to new developments, and share the UK's world-class computing technologies to find a solution to this virus. While many of the current members are competitors, it's important to realize that in the context of COVID-19, the world has united. Dario Gil, director of IBM Research, puts it this way: It's been a pleasure to work together with my colleagues from Google, Microsoft, Amazon, HP, and many others to bring the best of our respective institutions, working with our colleagues from academia and the many participating institutions, from Department of Energy to National Science Foundation to NASA. It's been extraordinary. Joining forces will only make our respective institutions stronger. It's a sure win for society. These emotions, these motivations are part of the reason why our Distant Reader Cord project was drawn to the HPC consortium and why we sought an award there. We were happy to receive an award of 70,000 service units and additional support from Microsoft AI for Good and the Los Alamos National Lab so that we could run our distant reader against the COVID-19 data source. So what you see on the screen now is an example of a view into a distant reader project. We affectionately call those study carols. In this case, Distant Reader transformed the COVID-19 content for those articles into a set of plain text files. Let's look at how that happens. Here you see me entering a search into the COVID-19 interface. This search is an index of all 130,000 plus articles. And to create a study carol, the Distant Reader queries the Solar Index, sends the articles matching the query to the Distant Reader cord. It caches the data set. This particular study carol that we'll see next was created from a 2020 May 28 query of the 2019 cord dataset articles on susceptibility and gender, with a query against susceptibility and gender with the year 2020 or 2019, looking for entities about women or men. This resulted in a subset of articles. After we queued the job, the Distant Reader went to work. It transformed the COVID-19 content for the articles that matched our query into a set of plain text files. Then the reader did text mining and natural language processing against the text files for the purpose of feature extraction. N-grams, parts of speech, named entities. The results of this process are a set of tab-delimited text files as output for each process. The whole of all those text files are then distilled into a relational database. A set of tabular and illustrated narrative reports are then generated against that data store. The return project file system is affectionately called a study carol. The carols are made up of many subdirectories and data files. A carol manifest describes each one in greater detail. A student, researcher, or scholar can peruse the study carol and its short narrative report for the purpose of informing a more traditional reading process. A website view of the carol file system, like you see here on my screen, shows a more verbose version of the narrative report and its analyses. Users can also download their carol for offload and reading. All study carols are self-contained. No internet connection is necessary to use them once they're downloaded. So let's talk about text mining COVID-19 and some of the issues. The COVID-19 data set is open, but not necessarily verified. Processing the metadata meaningfully alongside bag of words techniques in heterogeneous text documents demands attention to workflow, as well as sorting and ranking features. Linking back to the COVID-19 JSON version of the articles is not very useful to end users, as is providing link citations or resolvable DOIs. We're in the process of ensuring that those kind of resources are available to users. Our solutions for providing keywords and context also needs help so that our text mining analysis output can be enhanced to ensure that readers can access the portions of the text that they're most interested in. Some other issues surround scale versus portability. Early in the spring, we created a pilot distant reader carol that analyzed 13,000 or so full-text scientific and scholarly journal articles. The data set has grown 10 times since then to 130,000 articles. When we applied distant reader to the data set, the result was a study carol like you saw before. And we've since pre-processed the entire 130,000 item data set and indexed it with Solr, as you saw. The outputs of those carols are available at cord.distantreader.org. It's a traditional science gateway, and it lets users interact through a friendly GUI with HPC. We bring the data from the reader to the compute, and then we allow the user to download or share the results for further analysis. They don't need HPC capabilities of their own in order to explore a distant reader study carol and its outputs. Some of the things we need to work on next are efficiently consuming new versions into the corpus, modularizing to better include SciSpacey and other text processors, building on strengths and use cases for distant reading, tuning our named entity recognition and treatment of proper nouns, and ensuring that n-grams resolve back to their text strings in context. It's an open source project and community contributions are encouraged. You can visit our code on GitHub at github.com/EricLeesMorgan reader/projects. So what does it mean to think about verifying text mining outputs? Once we harvest the content, representing it back to a user in fair ways is something that we need to optimize our platform for. We know we need to capture ORCIDs for our carol creators and create persistent identifiers and DOIs for public carols so that people have findable, resolvable links back to content targets. We'd also like to ensure license checking for carol content and a way to make carol content license values visible. We know we also need to offer resolvable credit information for carol content so that we're verifying presentation of carol content as much as possible. We're working toward an API to allow end users to access our carol content not just through the GUI or through the downloadable carols, but also through an application programming interface. And we're thinking about what it might mean to provide an RDF representation of carol content. The best way to be informed about best practices for sharing of COVID-19 research is to consult the Research Data Alliance Working Group's COVID-19 recommendations and guidelines. Those are shared at rd-alliance.org/groups/RDA-COVID-19. The working group objectives are to clearly define detailed guidelines on data sharing under the present COVID-19 circumstances to help stakeholders follow best practices, to maximize the efficiency of their work, and to act as a blueprint for future emergencies. To develop recommendations for policymakers to maximize timely quality data sharing and appropriate responses in such public health emergencies, and to address the interests of researchers, policymakers, funders, publishers, and providers of data sharing infrastructures. I encourage you to visit the RDA COVID-19 recommendations and guidelines. Here on the screen, you see a slide from a presentation I delivered with Zoe Carina, who worked with me on the omics subgroup, that we presented to the International COVID-19 HPC Knowledge Exchange. If all of us literally eat our own dog food when it comes to doing data citation and software citation relative to our COVID-19 projects, we'll all have better reuse of not just our genomics data, but all of the data and software that we generate in our COVID-19 projects. There are guidelines in the RDA COVID-19 project for data and software sharing in clinical research, omics research, epidemiology, and social sciences, as well as guidance for community participation in data sharing, including via mobile apps, treatment of indigenous data relative to COVID-19, consideration of the legal and ethical requirements for data sharing during COVID-19, and examples of best use for research software sharing during COVID-19. In Distant Reader, our own approach to software citation stands on the shoulder of giants. Many of the scripts used in Distant Reader are written by authors from outside the project. So the onus is on us to provide proper software citation, Do that in such a way that in our own open source code sharing, it's clear whose software belongs to who and that they get credit, and that we have a way to increase the focus on the features in distant readers so that we can verify our outputs and inform them by the COVID-19 guidelines. I'd like to acknowledge those who have made the project possible: our lead developer, Eric Lees Morgan, the Distant Reader Team Project Cord, and the authors of the collection of scripts and applications that make up the Distant Reader. Also like to acknowledge the providers of the HPC infrastructure that allows us to run our jobs, and thank everyone here today for your work on text mining and sharing related to COVID-19. Thank you so much for listening. Please visit Distant Reader Team Project Cord at github.com/ericleesmorgan/reader. You may also visit these slides at osf.io/BNURJ on the Open Science Framework. Thank you for your time.